Okay, this is your test review for your systems of equations. Determine how many solutions exist for the following system of equations. I'm going to use substitution. You could put these in slope-intercept form and graph them both. Or what you could do is every time you see a y, you're going to replace it with 3x plus 3. So here I have 3x minus y, which I'm going to replace it with 3x plus 3. And that's going to give me negative 3. When I simplify by distributing the negative, the x's cancel, leaving you with a 0 minus 3. And that is true. Because it is true, it's not no solution, it's many solutions. If you were to graph this, they'd be the same line. Number 2, it says, what solution of the system of equations be classified? Once again, you could rearrange in slope-intercept form, or you could use elimination. I'm going to multiply this one by negative 2 to get negative 2x minus 2y equals negative 2, and I'd get 0 plus 0 equals 2, which is false, not true. Therefore, there's no solution, so you're inconsistent. If I were to graph these, they'd be parallel lines. Here, if x is 2, I'm going to replace x with a 2, and what do I get? Negative 1. All right. This one, it says, which system of equations has a solution that is inconsistent, meaning parallel lines? So here's an equation here, y equals 2x plus 3. So I need 2x plus 3, and then this equation has two different equations for it. So I know I need a 2x plus 3. So this has a 2x plus 3, and so does this one. So it's not these, it's one of these. Well, this equation is negative x plus 1 here or here. No. Here we have our 2x plus 3, 6x minus 3y. Yeah. So your answer is C. Number 5, which ordered pair is a solution set of these equations? If you graph in your graphing calculator, I will show you. So I'm going to put these in. X squared plus 5x plus 6. Hit the graph button. Okay, so when you graph, this is the one line. I don't know if you can see it. Why is this the lights being weird? Let's try this. Well, there's going to be a U and then a line. And what's the point that they intersect at? They intersect at this point. Okay, let's try to plug it back in. If negative 5 is x and 6 is y, go ahead and plug it in. Negative 5 plus 1, does that equal 6? Yes, let's try it with this equation. Y equals x squared plus 5x plus 6. If y is 6 and x is negative 5, will this work? All right, so we plug in negative 5 and then negative 5. We get 25, negative 25. They cancel, and it's true for both. Okay. Next page, we're dividing by 3. I don't like fractions, so I'm going to multiply by 3. When I do this, I'm going to get 6 over 3, which is 2x, 3 times y, which is 3y, and 3 times 14 over 3, which is going to be 14. Then I'm dividing by 5 and 4, so I'm going to multiply by 20. This is going to give me 80 over 5, which is going to be 16x. 20 times 3 divided by 4, which is going to be negative 15. and 20 times negative 10, which is negative 200. I'm going to use elimination now. So all I did was make it easier to work with. I'm going to multiply the top by negative 8 so that I get negative 16x, negative 24y equals negative 112. These are going to cancel. We'll get a negative 39y equals negative 312 divided by negative 39. And that's 8 for y. This is the only one with a y value of 8. Number 7, Anna burned 15 calories per minute running in X minutes and 10 calories per minute hiking for Y minutes. That explains this one. She spent a total of 60 minutes. So hiking and running is X plus Y. How many minutes does she spend hiking? Hiking. Y. So we need to solve for Y. So let's get rid of X. So 15x plus 10y, 700. Negative 15x plus negative 15y equals negative 900. These are going to cancel. We're going to get negative 5y equals negative 200. Therefore, y equals 40. Be careful. If you solve for x, you're going to get 20. Okay, number 8, it says, when solving the systems of equations, which expression could be substituted for y? So I want to substitute for y. That means I need to get y by itself here. Y equals negative 3x plus 14. So what would I substitute in for y? Negative 3x plus 14. Negative 3x plus 14. The next one, the perimeter of a deck is 175 feet. The length of the deck L is 6 feet longer than twice the width. Which systems of equations can be used to solve? Well, they all have this, but it says the length of the deck is 6 feet longer. If I'm longer, I'm plus 6. If I'm shorter, I'm minus, but I'm longer, so it's 2 times the width. So longer addition. Here on the back, these words are giving you 2 equations. Samantha purchased 5 roses for X dollars and 4 daisies for Y dollars and spent 32. Maria, 1 rose, 6 daisies, 22. So I need to solve for X and Y to answer these questions. I'm going to multiply by negative 5 to get negative 5X, negative 30Y, and negative 110. So I'm going to get negative 26, Y, negative 78, Y, Y equals 3. If I plug that back in, Y equals 3, I get 12, 32, so that's 20. So X is 4. So roses, daisies. So go through. A rose costs $1 more than a daisy. That's true. Sam spent $4 on each daisy. No. Sam spent more on daisies than roses. No. Sam spent 4 times as much. No. A. The length of a rectangle is 3 times the width. The sum of the length and the width is 24 inches. What is the length? Well, every time I see an L, I'm going to replace it with 3W. So 4W equals 24, W equals 6. But they want to know the length. So plug 6 back in. 3 times 6 is 18. Okay, and then Karen makes $5 per hour babysitting and 12 hours for a music lesson for a total of $139. But she worked for a total of 18 hours. So babysitting plus music is 18. We're going to multiply by negative 5. Get negative 90. They cross out. And then music would be 7. So if music is 7, so 7 hours plus 11, or 7 hours plus babysitting 11 hours. And it says how many hours you spend babysitting? It would be 11. Because you'd have to plug back in 7, 11, 18. All right. Bell's going to ring, so let me pause this for a minute. I lied. 2 minutes. All right. The price of a hamburger is H dollars. G dollars. He spent money. He spent money. So price and price. Okay. So once again, you would solve like you did over here. We're going to multiply each by a number, because if I have a 3 and a 2, I'm going to multiply by a -2 and a +3 so that I get a -6 on top, a -8 on top, and -20. But I wanted to get a +6 down here so that they cancel out and I get G equals 1. Okay. So G is a hot dog. So hot dogs are $1. If I plug it back in, that's 4, subtract 6, then hot dogs or hamburgers is 2. Hot dogs cost more than hamburgers. No. Hamburgers cost more than hot dogs. Yes. Okay, these aren't true either. All right, bottom one. If you put these both in the graphing calculator, they're going to go like this, and they're going to go like this. They do not intersect. Okay, and that's just the review part. The open-ended we can go over in class together.